This is the same problem as in the textbook with a few changes, some additional information. So here are some additional information I'm going to assume. Okay. Otherwise the problem is the same. So here is the demand given and the number of days in each of the months, and we know that the labor hours per unit is 1.6 hours. Hours per day is 8, and then regular wage rate is $10 per hour. Subcontracting is $20 per unit. Now, carrying cost per unit per month is 5. Hiring cost is per unit increase is $300. Firing cost is per unit decrease, that is $600. So these are the information data that is already given in the textbook. So now I have assumed some more, and I'm going to write these in a different color ink, so we'll know that these are the additional pieces of data that I'm assuming for this problem. So number of workers currently in the role, so current workers is 8. Now 25% of the regular time production is what is permitted in overtime. So overtime is limited to 25%. Now overtime wage rate, okay, so there is a premium, so per hour is $15. And then we have current inventory is 25. Okay. Safety stock. Okay. Safety stock here is the amount of inventory that you have to maintain. You cannot go below that level in any of the months, and that we are assuming as 20. Now production rate, okay, I should have included that here, so I am assuming a production rate of 40. So by the time I make this page available to students, I will include that over there. So now same problem as in the textbook, but with some modifications. Now here one of the things that you need to note, and this is very important because this will determine how we have to compute our hiring and firing costs and how we have to compute the production rates. So here the hiring and firing costs should be based on hiring, firing costs are based on increase / decrease of production day, production rate per day. Okay. And on what time basis must the production rate be computed? Per day basis or monthly basis? So this is production should be computed on per day basis. I want to emphasize this so we'll remember when we do the problems in the next page that we will compute these numbers correctly. Now let's go to the next page, and here we're going to compute some basic factors that we will need as we go along to develop our production plans. So determine the production rate per worker per day. Remember, we used this number in the slides. So now let's look at how to compute these values. So this is given by, this is per day basis, so we have to make the computations on per day basis. Hours per day divided by labor hours needed per unit. So this is another name for this is standard hours. So you have to remember that. So it's 8 divided by 1.6. Okay, remember that these are given. So this is 5 units per worker per day. And this is an important factor for us to determine how many workers we need. Suppose we set the production rate as 40 units a day, then 40 divided by 5 will give you we need 8 workers per day. So next question is, what is the wage rate per worker per day? Once again, this is on per day basis. If it is not, if the number of days are same and it is not given, then we will use per month or per quarter. This is hours per day multiplied by wage rate per hour. So 8 times $10. Again, we know 8 hours a day and our wage rate is $10. So it is $80 per worker per day. What is the cost of producing an item in regular time? So this is standard hours. So that's labor hours needed per unit. So standard hours. I'm going to use these two terminologies interchangeably. So standard, you should understand that standard hours means how many labor hours are needed to produce 1 unit times wage rate per hour. So that is 1.6 hours times $10. So that is $16 per unit. Next is, what is the cost of producing an item in overtime? So that will be same like here, except that the wage rate is going to be the overtime wage rate. So standard hours times overtime. I'm going to use O.T to mean overtime. So overtime wage rate per hour. So that is equal to, again, still 1.6 hours times overtime wage rate. So remember, we assumed overtime wage rate is going to be $15 an hour. So 1.6 times $15 will give you $24 per unit. Okay. Next, if the required production in a given month is 50, how many workers will be needed? So that will be required production per day. So in this case we are doing the computations per day, therefore it is per day. So it's not necessary that it has to be per day in all problems. In this problem, the computations are on the basis of per day. So divided by production rate per worker per day. How many units one worker will produce per day? So that is 50 divided by, remember we computed the production rate per worker in the first problem. So right here. So we'll use that over here. So we'll need 10 workers. So what is the overall average net demand? So here there is a particular meaning for this net demand. So net demand for 6 months. So first we have to look at the total net demand. It is total demand, okay, but there is some current inventory available, so we can use some of that current inventory towards the total demand. So the entire demand need not be produced. So minus current demand, current inventory but some of this current inventory will have to be set aside for safety stock. So the net is what we have to produce. So sometimes if the current inventory is not sufficient to meet the safety demand, so this will be a negative number, so negative will get added to your total demand. So what is the total demand? So here if you add, okay, we already added all this in our PowerPoint presentation. So this sum is 6200 and this is 124 days. So 6200 minus our current inventory is 25 minus safety stock is 20. So current inventory 25, safety stock is 20. So that is equal to 6195. So that's our net demand. So average net demand then per day is 6195 and there are 124 days, so that is equal to 49.95 per day. And let's round this to 50 units per day. So you have to be very careful about rounding. If you round up like this, it's not going to matter. You'll produce a little bit more than what you need. But suppose if this had been 49.05 and you round it down to 49, then you will produce less than what you require and you will end up with less safety